Hello, I'm Grant from Maker's Vlog, and today I'm building a Faraday cage. Now, if you've seen any of my last videos, you will have seen that I've been doing a lot of stuff with jamming and devices like that. And I have permission to do those sorts of tests with those devices under certain criteria. And I have said that, if you check the laws in your country, it may not be legal for you to even build one. But most countries have the criteria that if it's in a Faraday environment, so a sealed environment for RF, you can use them. So I thought I'd show you how to build one here, and I have a project coming up where I need to have a Faraday cage. I'm building an EMP generator, and for that I need to be able to contain it. So I'm building this, and I thought I'd show it off because in that way it gives you a safe way to demonstrate some of these builds that I've been doing. So very quickly, I'm going to talk about what Faraday cages are. Now, all they are is an insulated environment using a conductive material, which sounds counterintuitive. You're insulating using a conductor, but it's essentially an enclosed area with a conductive material, and it essentially dissipates RF energy. There is lots of very cool science about it and explains how this all happens, but for the sake of argument, just for the meantime, just accept that it dissipates RF. Now, these are used more commonly than you might think, i.e. this little chip here that you've seen me use. This is an RF amplifier. This cage here, this little enclosure, is a Faraday cage. And that's there to protect not only the components inside the device from stray RF energy, but it also protects other devices outside. Because this is an amplifier circuit, the RF energy can escape through wires and other components. So in order to stop that interfering with whatever it is you might be using this amplifier for, they contain it within a Faraday box. And a lot of components do this. Most electronic components will have something like this in there to protect not only their components, but everything else outside them. So that's the boring stuff out of the way. Let's actually look at what I'm using here to build this Faraday cage. It's a box. Now, I'm not sponsored by HelloFresh, by the way, it was the biggest box I had on hand that was the right size. A box, whatever size you need to contain the device that you're wanting to test or potentially want to test. Some kitchen foil, tin foil or aluminium foil, or aluminum if you're in America. And if you want to get fancy with it, now I am, because I want to be able to record what's happening in here, even though there might not necessarily be much to see. So I'm using some wire mesh, which might be difficult for you to see there. This is just what we call chicken wire. And a little LED strip, which I'm going to put in the inside so I've got a bit of light in there. Now, depending on what you're wanting to make this Faraday cage for, putting a light in there is maybe a bad idea. If you're wanting to contain this so that whatever's inside is isolated from RF outside of the Faraday cage, I wouldn't put a light in, because then you're introducing a source of RF energy. So whenever you put this in, it's creating energy. Now, I don't mind that, because all I want is whatever's inside to not get out. And this could provide a way for the signals to get out, but I'm willing to take that chance. And also it might be a good demonstrator, because the EMP might blow this whenever I get around to making it. So we'll see how that goes. So all you do is you take your kitchen foil and line the inside with foil, inside of the box with foil. So I'm going to do that, and I'll bring you back whenever I've got that done. So there it is. That's it now, all coated on the inside with the tin foil. It doesn't need to be perfect by any stretch. So if there's a few wee gaps or anything like that there, don't worry about it. It won't impact it too much. Just to fix it on the inside, I did start using just some super glue, but then I remembered that I had some spray adhesive, so I used it instead. Both would work fine. I was also going to use hot glue, but I thought it might be a bit too bumpy, just for aesthetic purposes more than anything, not that it looks the prettiest anyway. So that's it. So what I'm going to do is I'm going to do a quick test without a bottom. So at the minute this is going to sit sort of like that over the top of whatever it is I'm wanting to Faraday. I am potentially going to make a base for it that's also got foil on it. That's why I've cut off the sort of top flaps. I'm going to make them into one base if I need it. If I don't need it, happy days. So I'm going to do a test now with the jamming device that I made in one of my other videos. You can see that up there. And I'm going to see once it's put into the Faraday cage, will it block the transmission? So yeah, let's get that set up. So as you can see there, you can see the little peak coming up, and it is underneath the box. So it is not blocking it yet, so I do need to put a base underneath it. So I'm going to go put that together now, and I'll bring this back when that's done. So that's it done. One bit of advice I would give is layers. So I've done 4 layers of foil on the inside, and again on the lid here, and you'll see there's 4 layers of foil the whole way around. If you can get your hands on that foil tape, the adhesive stuff, it would make your life a whole lot easier. I used spray adhesive for most of this, and it took a while. The lid is just the 2 flaps that I've taped together, and I'm going to paint this whole thing probably black. Maybe I've got a sort of army green. I might give that a go, just to show it painted. And I had an issue with this. Now I have since realized what that issue is, and it's this cable here. I don't know if you can see that. Yeah, that one there. And it's acting like essentially an escape route for the RF energy. So whenever I put this on here, you can see over here, this is the signal that the jamming device is putting out. And if I put that on, you will notice that the signal's still getting out. So does that mean the Faraday box doesn't work? No. What it means is this cable here is acting like an escape tunnel for the RF energy. It's radiating through here. So if I cover this, see it drops? That's because I'm essentially covering the hole. And whenever I let go, and off, and on. So that's what you need to be careful of whenever you're using one of these boxes, that everything that you need to run the device is contained within it. Because if there's a wire coming out or something like that, it's an escape route for the RF energy. Now, this is particularly bad because this is powering the board. So the RF, which travels through a phenomenon called skin effect, can come back down this line. And because it's not a very well made circuit and it's not well insulated, that's what's happening. It's coming back, and that's why we're still seeing the signal. So because of that, I was going to put a light, this wee LED in here. And I might still do it, but I am concerned now that this might act essentially like an escape tunnel for the RF energy and allow it to get out. So I'm going to do that. I'm going to put it in and see if it works. If it works, happy days. If it doesn't, then I'll take it out. And same with the window. So I was going to use this chicken wire, just layered like so, and have a window somewhere on this so that I can see in. Again, I'm not too sure whether that's going to be effective because of well, just the nightmare I've had with getting this running. But I think my main issues came from having this wire coming out. Okay, so I have very, very briefly made this somewhat portable. It's a very temporary patch job, and it definitely needs a lot of improvement. But it gets rid of that cable that you seen coming out the side that was giving me the issues because it was radiating down that. So what I'm going to do, flick this on, it's ready to go, and pop it in here. And I've got a bit of plastic in there that's sitting up on. That's just to stop any of the pins shorting off the tinfoil. And we'll pop that on. Right, as I say, this doesn't need to be a perfect seal because it's not like air escaping. As long as it's not bigger than the wavelength or a derivation of the wavelength, the signal will be stopped. So if you ever look up Faraday cages, you might see that a lot of them have loads of wee holes on them. So it doesn't need to be an airtight seal, but as long as it's on there. And I've got the hack in the box open up here, and you can see there is sweet FA showing up on the spectrum. So that's it. That's how you make a Faraday cage. Well, Faraday box. The only thing you didn't see was I gave it a bit of a paint job and made a lid handle just out of duct tape, so I can easily lift it off and put it on. So a bit more testing needed on it. I just want to make 100% sure that this is completely proof and can handle the signals that is going to be subjected to whenever I make the EMP device. So definitely more testing needed. So with that in mind, my next project is going to be upgrading this little jamming device, which will be in another video. Removing this, which is the mains power for it, and I'm going to be using these little boards here, which are lithium ion charge controllers. So that's going to be my next project, as well as creating the EMP device. So if you want to see that, subscribe, like, all that good stuff. We also have a Patreon if you want to support the channel, and a Discord as well down below if you want to come on and talk about this or my horrendous paint jobs. So yeah, thanks for watching, and I'll see you later.